Wind load calculator according to the Euro code 1991. The most common cases with this wind direction: positive pressure on front wall, section on side walls, uplift on roof, and section on rear wall. I am excited to share with you my video about automation of the wind load calculation. In the next few minutes, I will show you how to calculate the external wind force on duopitch roofs. This building with the positive pitch angle alpha and this one with the negative pitch angle. Here is the top view of the roof in which the divided zones are located. Here is the procedure for determining the external wind force FWE on duopitch roofs, and can be determined following this equation. CSCD is the structural factor, WE is the external wind pressure, A is the reference area of each zone, CSCD equal to 1 if A, the height of the building less than 15 meters, B, natural frequency for facade and roof elements greater than 5 Hz, C, the height of the frame buildings with the structural walls less than 100 meters. Alternatively, for case A, B, and C above, CSCD can be derived from 6.3.1 Euro Code 1991. CPE is the external pressure coefficient and can be determined from the table 7.4 Euro Code 1991. QP is the peak velocity pressure and depends on the region and the height of the building. B is the width of the building perpendicular to the wind direction. D dash is the pitch length parallel to the wind direction. At wind direction 0, the pressure changed rapidly around pitch angle alpha from -5 to 45 degrees. So both positive and negative values of external pressure coefficient CPE are given in the following table. Below the recommended values of external pressure coefficient CPE for duopitch roofs. As mentioned earlier, for angles from -5 to 45 degrees, two values for external pressure coefficient CPE are given. For duopitch roofs, 4 cases should be considered where the largest or smallest CPE values of all areas F, G, and H are combined with the largest or smallest CPE values in areas I and J. Below are the external pressure coefficient CPE for case 1, plus and plus combination. Here are the external pressure coefficient CPE case 2, plus and minus combination. And here the external pressure coefficient CPE case 3, minus and plus combination. The last one is the external pressure coefficient CPE case 4, minus and minus combination. CPE of intermediate pitch angles can be determined by linear interpolation according to the two equations below. First equation, to determine CPE of the first intermediate angle. Second equation, to determine CPE of the second intermediate angle. Here is an example for linear interpolation for intermediate angles between 60 and 75 degrees. CPE of 65 equal to CPE 75 minus CPE 60 divided to 3 plus CPE 60. And this is the value of pitch angle 65. In the same way, we can find the CPE of angle 70 degree. And this is the value of the intermediate angle 70 degree. External pressure coefficient CPE for building elements with the loaded area A between 1 and 10 square meter can be determined from the graph and its logarithmic equation below. CPE equal to CPE1 minus, between brackets, CPE1 minus CPE10 times logarithmic A. A is the area between 1 and 10 square meter. In this video, we take a wind load case 4 with the wind direction 0 and a positive pitch angle alpha as an example to calculate external wind force FWE on duopitch roofs. Building dimensions needed to calculate CPE. Alpha is the pitch angle, H is the height of the sidewall, D is the depth of the building parallel to the wind direction, B is the width of the building perpendicular to wind direction. Calculated dimensions based on the given dimensions above. In other words, calculated from the given dimensions above. The calculated dimensions below needed to determine loaded area of each zone of the duopitch roof, total height of the building, length of the roof parallel to the wind direction, taking into account the slope length. E is minimum value of P or 2 times the height of the building. Area of each zone is calculated from the interdimensions alpha 35 degree, H 5 meter, depth of the building 25, and width of the building 15 meter. External pressure coefficient CPE for buildings with loaded area A between 1 and 10 square meter can be determined using the logarithmic equation below. CPE equal to CPE1 minus, between brackets, CPE1 minus CPE10 times logarithm A. A is the loaded area between 1 and 10 square meter. Here is an example to determine the external pressure coefficient CPE for zone F with a loaded area of 5,63 square meter. CPE equal to CPE1 minus, between brackets, CPE1 minus CPE10 times logarithm A. The outcomes is minus, 5. And this is the CPE of zone F. Here is the final results of CPE after linear interpolation for intermediate pitch angle alpha. Here is 35 degree, and logarithmic interpolation for CPE1 and CPE10 for every zone area of the duopitch roof. CPE usually depends on pitch angle alpha. Final result after 2 times interpolation, CPE for zone F, zone G, H, J, and I. Here are final results of CPE after linear interpolations for intermediate pitch angle alpha and logarithmic interpolations for CPE1 and CPE10. This pitch angle calculator is adjusted for every 5 degrees. These are the values of CPE by pitch angle 5. By clicking on one of these 2 arrows, we get CPE for each pitch angle from 5 up to 75 degrees. And these are the values of external pressure coefficient by pitch angle 75. Now we need CPE values for pitch angle 35 degrees. In this way, we get final results of external pressure coefficient for angle 35 degrees. After defining CPE values, we can determine external pressure WE in every zone. WE equal to QP times CPE. QP is the peak velocity pressure at reference height Z. CPE is the external pressure coefficient. Reference height rounded up to 15 meters to match the height values in the Regals table. The CPE values in each zone multiplied by QP value, here it is 0,66, give us the values of external pressure WE in every zone of the duopitch roof. Determination of external wind force FWE. FWE equal to CSCD times summation of WE times A reference. CSCD is structural factor and it equals 1 if A, the height of the building less than 15 meters, B, the height of frame building with the structural walls less than 100 meters, C, natural frequency for facade and roof elements greater than 5 Hz. Glazing spans smaller than 3 meters usually lead to natural frequencies greater than 5 Hz. Alternatively, for case A, B, and C above, CSCD may be derived from 6.3.1 Euro Code 1991. External wind force FWE calculation based on the following information and dimensions. Pitch angle alpha 35 degree, wind load case 4, height of the building less than 15 meter, thus CSCD equal to 1, terrain category region 3 built, thus QP from the table of peak velocity pressure as a function of height equal to 0.66 kN per square meter, wind direction 0, D is the depth of the building parallel to the wind direction equal to 25 meter, and B is the width of the building perpendicular to the wind direction equal to 15 meter. After defining external pressure WE at reference height ZE, and after calculation the area of each zone and structural factor CSCD, we can determine external force following this equation. FWE equal to structural factor CSCD times summation external pressure WE times the reference area of each zone. Here is the calculation of external force FWE for zone H as an example. The result of wind force equation 18.6 kN is the wind force on zone H. Precision and accuracy are essential features of our calculations. I am happy with the end result, and I will be even happier if you find it valuable and can make the most of it. I hope and try to make my work as accessible as possible to the relevant group, especially civil engineers and architects. If you want any further information, feel free to contact us at info@rasemengineering.com. Are you interested in the wind load calculator? You will receive it as spreadsheet version for free by email for a week.